Very good evening, my dear third semester mechanical and automobile students. Today I will discuss three derivations. These are the most important problems for your examination. First one is what is isothermal process and derive work done during isothermal process. Second one is what is polytropic process and what is the derive the work done during polytropic process. Third one is what is adiabatic process, derive work done during adiabatic process. Now I will discuss one by one. First derivation is what is isothermal process, derive work done during isothermal process. You know that isothermal means temperature remaining constant. It is also known as isothermal process is that process of expansion or compression of a gas during which temperature of the gas remains constant. It is also this isothermal process follows the law Pv is equal to constant. Then what is the work done during isothermal process? Now let us consider an instant K when the pressure of the gas is P and its volume is V. It has been shown in the figure. This is the diagram, pressure volume diagram. Let us consider point K where pressure of the gas is P and volume of the gas is V. From this point K, let the volume increases by a very small amount dV. When very small amount of volume increases, automatically very small amount of work done during this small increase of volume is given by dW is equal to Pdv. पिलाମାନେ तुम जानथो जेतेबेले वॉल्यूम चेंज होबो किछि वर्क डन हैला होबो then therefore since very small amount of volume increases, therefore very small amount of work done during this small increase of volume is given by dW is equal to Pdv, where W is equal to required work done during change of volume from V1 to V2. Now integrating both sides, we have dW with the limit 0 to capital W is equal to Pdv with the limit V1 to V2, or after integration we have W is equal to Pdv with the limit V1 to V2. This is the equation 1. In this position, this is the first position 1. Here pressure P1, V1, T. Here at point 2, pressure is P2, volume is V2 and T, because temperature remains constant. In this position, at this point 1, temperature and point 2 is also same. Since isothermal process follows the law Pv is equal to C, we have also written as Pv is equal to P1 V1, or we can write as P is equal to P1 V1 by V. Putting this value of P in equation 1, ये equation 1 ने हमें कौन करिया ना P रो वैल्यू टाको हमें पुट कर देबा. Therefore W is equal to P1 V1 by V dV with the limit V1 to V2 is equal to P1 V1 with the limit dV by V with the limit V1 to V2, because P1 V1 is equal to constant term. Since Pv is equal to constant, P1 V1 is also constant, or W is equal to P1 V1. This one is constant term. A P1 V1 टाला constant term. तमे जानि छ dV by V आर इंटीग्रेशन होची log E V with the limit V1 to V2, or we can write as W is equal to P1 V1 log E V2 by V1. Again, for isothermal process follows the law P1 V1 is equal to P2 V2, or we can write as V2 by V1 is equal to P1 by P2. Then this equation becomes W is equal to P1 V1 log P1 by P2. तेणु तुम पे जदि लिखिपर W is equal to P1 V1 log V2 by V1 or W is equal to P1 V1 log P1 by P2. These two terms are the derivation of work done during isothermal process. Next, I will discuss what is polytropic process and derive the work done during polytropic process.
1.
Now, second one is what is polytropic process? Derive work done during polytropic process. You know that polytropic process is that process of expansion or compression of a gas which is neither isothermal nor adiabatic process, but is a process in between isothermal and adiabatic process. तुम जानिच adiabatic process follow the law P V to gamma is equal to constant, where gamma is equal to 1.4, but isothermal process is equal to P V is equal to constant. तेणु ये जो polytropic process टा 1 एवं 1.4 मध्य रहिबो इट्स वैल्यू. That means what is a process in between isothermal and adiabatic process. Polytropic process follows the law P V to the power n is equal to constant. Now, what is work done during polytropic process? Let us consider an instant K when the pressure of the gas is P and its volume is V. It has been shown in the pressure volume, that is PV diagram.
1.
From this instant K, let the volume increase by a very small amount dV. Then very small amount of work done during this very small change of volume is given by dW is equal to P dV. तुम जानिଛ पिलाମାନେ, this is the at position 1 where pressure of the gas is P, volume of the gas is V and the temperature of the gas is T. At point 2, pressure of the gas is P2, volume of the gas is V2, temperature of the gas T2. From this point K, here pressure is P and volume is V. Since the volume increases very small amount, then small amount of work done is found out. Therefore, dW is equal to P dV, where W is equal to required work done during change of volume from V1 to V2, or we can write as dW with the limit 0 to capital W is equal to P dV with the limit V1 to V2, or after integration we have W is equal to P dV with the limit V1 to V2. This is the equation 1. Since polytropic process follows the law P V to the power n is equal to constant, we have P V to the power n is equal to P1 V1 to the power n, or we can write as P is equal to P1 V1 to the power n divided by V to the power n. Putting this value, we have W is equal to P1 V1 to the power n divided by V to the power n dV is equal to P1 V1 to the power n within limit dV by V to the power n with the limit V1 to V2. आमे कहीं P1 V1 to the power n रा पता करले ना, since P1 V1 to the power n is equal to constant term. Therefore, we can write W is equal to P1 V1 to the power n within limit V to the power minus n dV, because तले अच्छे V to the power n ऊपर नेले V to the power minus n dV. तो मैं जानी चो integration of x to the power n dx is equal to x to the power n plus 1 by n plus 1. Similarly, integration of v to the power minus n dv is equal to v to the power minus n plus 1 divided by minus n plus 1 with the limit v1 to v2. Then we can write as p1 v1 to the power n divided by minus n plus 1 with the limit v2 to the power minus n plus 1 minus v1 to the power minus n plus 1. After multiplication, p1 v1 to the power n into v2 to the power minus n plus 1 minus p1 v1 to the power n into v1 to the power minus n plus 1 divided by minus n plus 1. Or we can write as p1 v1 to the power n into v2 to the power minus n plus 1 minus p1 into v1 to the power n minus n plus 1 divided by minus n plus 1. Or we can write as p2 v2 to the power n into v2 to the power minus n plus 1 minus p1 v1, because plus n minus n cancel, therefore we can write as p1 v1. आमे कौन कले p1 v1 to the power n जगह लिखि परिबा p2 v2 to the power n, because p1 v1 to the power n is equal to p2 v2 to the power n. Or p2 v2 to the power n minus n plus 1 minus p1 v1 divided by minus n plus 1 is equal to p2 v2 to the power n minus n plus 1. तुम जानिच यही जिस कहीं गला ना x to the power m into x to the power n is equal to x to the power m plus n. Here m is equal to n is equal to minus n plus 1. से लिख देली p2 v2 to the power n minus n plus 1 divided by p1 v1 divided by minus n plus 1. Or minus taking common minus p1 v1 minus p2 v2, because plus n minus n cancel, is divided by taking common minus n minus 1, therefore minus minus cancel, minus minus cancel, we have p1 v1 minus p2 v2 divided by n minus 1. Therefore work done during a polytropic process is given by p1 v1 minus p2 v2 divided by n minus 1. This is the required work done during polytropic process. Now I will discuss another derivation. Third one is, what is adiabatic process? Derive work done during adiabatic process. You know that adiabatic process is that process of expansion and compression of a gas during which no heat transfer takes place between the gas and any external source. Generally, adiabatic process follows the law P v to the power gamma is equal to constant, where gamma is equal to Cp by Cb is equal to 1.4. What is Cp? That it is specific heat at constant pressure, and Cb specific heat at constant volume. Then what is work done during adiabatic process? Similarly, let us consider an instant k when the pressure of the gas is P and its volume is V. It has been shown in the figure. In this figure, you can see this is the pressure volume diagram. Here point 1 P1 V1 T1 and point 2 P2 V2 T2. Here the point K, where here pressure of the gas is P and volume of the gas is V. Now from this point K, let the volume increases by a very small amount dV. then very small amount of work done during this very small change of volume is given by dW is equal to P dV. Here this is the point K. Here pressure of the gas is P and volume of the gas is V. Then very small amount of volume is changes, that is dV. ये जो माने स्मॉल वॉल्यूम चेंज है किसी स्मॉल अमाउंट ऑफ वर्क डन भी पड़ुला, देयरफॉर dW is equal to P dV, where W is equal to required work done during change of volume from V1 to V2. Here this is the V1, this is the volume V2, or we can write dW with the limit 0 to capital W is equal to P dV with the limit V1 to V2, or after integration we have W is equal to P dV with the limit V1 to V2. This is the equation 1. Since adiabatic process follow the law P V to the power gamma is equal to constant, we can write as P V to the power gamma is equal to P1 V1 to the power gamma, or P is equal to P1 V1 to the power gamma divided by V to the power gamma. Putting the value of P in equation 1, ये equation में हमें क्या करना ना, ये जो P रे value हमें put करिबा. We have W is equal to P1 V1 to the power gamma divided by V to the power gamma dV with the limit V1 to V2 is equal to P1 V1 to the power gamma with the limit dV divided by V to the power gamma with the limit V1 to V2. Since P1 V1 to the power gamma is equal to constant term, or W is equal to P1 V1 to the power gamma is equal to integration of V to the power minus gamma dV with the limit V1 to V2. 1. Or W is equal to P1 V1 to the power gamma with the limit V1 to V2 V to the power minus gamma dV, because V to the power gamma ऊपर पड़ गला पर V to the power minus gamma, or P1 V1 gamma with the limit V to the power minus gamma plus 1 divided by minus gamma plus 1 with the limit V1 to V2, or P1 V1 to the power gamma divided by minus gamma plus 1 with the limit V2 to the power minus gamma plus 1 minus V1 to the power minus gamma plus 1. आमे क्या करिया ना आपरे आमे एटा गुणी दबा, मल्टीप्लिकेशन कर दबा. W is equal to P1 V1 to the power gamma into V2 to the power minus gamma plus 1 minus P1 V1 to the power gamma into V1 to the power minus gamma plus 1 divided by minus gamma plus 1. Actually ये derivation टा similar to polytropic process. Polytropic process कौन होच पिला माने केवल लिखा होची P V to the power n is equal to constant, but adiabatic process P V to the power gamma is equal to constant, or W is equal to P1 V1 V2 to the power minus gamma plus 1 minus P1 V1 to the power minus gamma plus 1 minus gamma divided by minus gamma plus 1, or we can write as P2 V2 to the power gamma into V2 to the power minus gamma plus 1 minus P1 V1. Since P1 V1 to the power gamma is equal to P2 V2 to the power gamma, or P2 V2 to the power gamma minus gamma plus 1 minus P1 V1 divided by minus gamma plus 1, or we can write as P2 V2 minus P1 V1 divided by minus gamma plus 1. Taking common minus P1 V1 minus P2 V2 divided by gamma minus 1. Minus minus cancel, or we can write as P1 V1 minus P2 V2 divided by gamma minus 1. or W is equal to P1 V1 minus P2 V2 divided by gamma minus 1. This is the required work done during adiabatic process.
1.
Kindly refer to my notes and मोर चैनल को लाइक शेयर एवं सब्सक्राइब करंतु एवं कमेंट दियंतु एवं प्रैक्टिस करंतु। ये जो डेरिवेशन गुड़ाक जो 3टा डेरिवेशन बहुत इंपोर्टेंट सेमिस्टर एग्जाम पे, तेणु पूरा डिटेल लिखाई धीरे धीरे बुझ, जिससे तुम सक्सेसफुल हो आशा। थैंक यू।